Welcome to Todd and Eve's show, where I have conversations with interesting people and attempt to learn out loud for the benefit of myself and anyone who listens along. And this week we have Matt Parlmer on the podcast. Matt is a fire hose of information spraying wildly into the world on Twitter and in real life when you speak to him. And it's actually really funny. Matt is super knowledgeable about database infrastructure, about 3D printing, about politics, about extremist politics on both the left and the right. And when Matt speaks, he speaks in these giant reference-laden dense paragraphs that are fascinating, but also kind of hard to keep up with, which has given me a little bit of insight into some of my own behavior and given me some empathy for people who I've, inundated with dense information and reference-laden paragraphs. Like, oh, okay, yeah, sometimes it's hard to really keep up with someone when they're just talking about a lot of stuff that they know about, which is awesome for podcasts. So this is a fantastic conversation with Matt. He is the co-founder of a new company that is attempting to, as he says, eat upstream complexity for people in 3D printing, right? So there's potentially a new wave of manufacturing coming to small businesses to local producers, et cetera, based upon some of the dynamics of the overall 3D printing situation. So that is very exciting, and I look forward to seeing what comes from that. So check out this conversation with Matt Parlmer. All right, Matt. So is it time to build?
Dude, it has been since the 70s. Like, we got to get off our asses here. Yeah, it is. It is. I mean, I don't know. Do you usually publish these like pretty immediately?
It kind of depends. I usually try to keep a few like in the can and just sort of move them around. I'm actually not sure when I will put this one out, but if you want to say something timely, we could potentially bump it up.
reason being is because, just in the last few weeks, we've had a lot of extremely strong indications that, we need to go build a bunch of stuff and urgently, the Texas thing.
And for reference, this is early March 2020.
Yeah. So Texas got hit with a not particularly bad snowstorm and completely fell over. And in ways that are, consistent with infrastructural failures throughout the rest of the country. We've had increasingly bad telco service over the last 3 or 4 years. Fiber isn't deployed everywhere. Cold chain logistics are becoming an issue with the vaccine distribution. All this stuff. A lot of signals that a lot of strong signals that a large swath of what we live amongst needs to be replaced.
So what should we do about it? I mean, that's like a bunch of different, large institutional things that need to be fixed and are underperforming. And things like that seem very hard to fix, right? That, if you're an employee at that company, you're just like, oh yeah, we all know that this is kind of broken, but it's not my job and it's hard to make it work. And then that happens enough times and you get problems.
Right. I think it's a number of different things. So if you look at American engineering culture outside of computer science stuff, where there is still some pretty impressive ambition, you see a lot of folks who just don't reach for the optimum solution when a proven solution that is usually suboptimal is there. Right. So you see a lot of, and this is there's a commercial pressure for this, but I also think there's a regulatory and sort of cultural pressure as well for engineers and, and their managers to make extremely conservative decisions in the interest of mitigating risk. But the problem is that if you just keep making conservative decisions all the time, you don't improve anything. And then all of a sudden, some sort of big correlated failure comes around and all of your systems fall down at once. And you're left asking what the hell were we thinking? I think the last 12 months have been just case study after case study in that.
Yeah, I mean, I think that a topical example of that is with, you'd say like vaccine messaging, right? Where each individual person is trying to mitigate the risks themselves of saying something wrong or giving people license to do bad stuff by being optimistic about vaccine rollout or vaccine efficacy, and doesn't want to say like, yeah, if you get a vaccine, things are going to go well for you. And then the chorus of people saying stuff like that then creates confusion and doesn't mitigate vaccine hesitancy. And so you have fewer people getting a vaccine, which then extends a pandemic, right? It's just this,
right.
Oh, that's not good. That's not what we want to have.
Massive net negative result for, because of what we perceive to be like understandable caution. Right.
Yeah.
And that sort of stuff is like, this gets to our, like, I think we have this like cultural cult of risk management that is extremely unhealthy. Like the Challenger blows up, right? And then we just decide not to invest in heavy space access systems until Elon comes around, right? Or you have something like Chernobyl go down or 3 Mile Island go down. And the reaction isn't to say like, oh, well, this class of reactor needs to be replaced with a completely new novel class of reactor that is, not is just like at a physics level, not capable of failing in this like, wide set of ways that light water reactors are capable of failing in. And, no one goes and does it though, because the easier thing institutionally and bureaucratically is to just say like, we're not going to do it. We're going to cover, we're going to try to avoid tort. We're going to try to avoid consequences for elected or appointed officials. And we're just going to, and we're just going to kind of cruise. And when you make big decisions around that as a culture, those eventually trickle down to everything. And, I think we're starting to sort of reap what we sowed with that in the 70s.
Yeah, I think that there's also, all the examples that you cited seem to potentially fit like a model maybe based on something like arachnophobia or fear of snakes or whatever, where it's very easy for humans to become afraid of those types of things. Right. That we sort of have like in our brains a spider-sized nodule on like the fear center that's like, yep, I'm like ready to be afraid of the things that look like that. Right. And it's like, yes, I am ready to be afraid of like a large fiery explosion in the sky. I'm ready to be afraid of someone sticking a needle in my arm. I'm ready to be afraid of, like nuclear and like weird radiation sounding stuff. Like those are all things that I'm like really ready to be afraid of. So it's easy then for the risk calculation to get kind of screwed up with things like that.
Totally. So it's not irrational to have the fear of bad things. That's very rational and extremely healthy. It's bad when you weight it wrong. And totally. I think we collectively made a decision in the sometime in the 70s that swung us, and this is in the Anglo world, writ total, not just the US. We made a decision sometime in the 1970s that we were going to switch to aggressive risk mitigation, according to this sort of like weird misinterpretation of the precautionary principle. And then we wrote a lot of that into law. And then all of a sudden, magically, across the Western world, all the R&D programs stopped working at once, and all the investment in developing novel forms of technical infrastructure, whether it's power generation or whether it's any number of other things, that all went off the rails. And you're left wondering like, okay, well, one area where we didn't do that because it was basically costless and no one relied on it, and the telephone grid was always going to be there, and this could just ride on top of it, was communications and computing, right? So that was the one area where nobody got in the way, and we went from tricorders being presented as a thing in the 60s to actual fucking tricorders. like real life, like it can do blood sampling, it can do mass spectrometry, it can do, you know, all this stuff, right? With a couple little attachments in like what, 40 years? You know, it's something where I don't think people recognize like the cost of just like the cultural mentality around certain things and how that can just trickle into you know, into other you know, decision-making processes and influence them perniciously.
Yeah, I mean, you mentioned the situation in Texas as a particularly salient example, right? Somewhat topical as well. And I mean, you seem to be pretty knowledgeable about a lot of the details there, right? And, you know, I don't know much more than a few news articles and a few Twitter posts. So I'm curious to get your take on it. What's the deal with Texas, right? I mean, can you tie that into this larger narrative?
Yeah, like it's Texas. Texas is what happens when you I'm gonna get myself in trouble, but screw it. Texas is what happens when you you know, when the only risks you take are on you know, in your energy generation capacity building are on you know, things that are already proven out in the Netherlands in 1600. You know,
what do you mean by that? Elaborate on that.
Wind power. You know, AKA the great subsidy to the, you know, like, well, not the great, one of the great subsidies to the American aerospace industry. You know, that's all aerospace grade aluminum. You know, it's installed in large, you know, it's installed in these large wind farms. You know, in Texas's case, most of these are in Oklahoma or in places in North Texas. You know, and then when you know, you have a big correlated failure, like say the temp's going way low, you know, suddenly that entire generating infrastructure is, you know, shut down. And then you know, then for the same reason, you know, your natural gas goes off because things got too cold. Not to pick on Texas too much, because like up in Michigan, you know, where I'm from, you know, we back in January 19, we had a cold snap and a frickin' like natural gas storage facility blew up. Right. So this isn't just Texas. Texas is a microcosm of a larger set of decisions that have been made nationally. I think the immediate cause of the Texas situation was just a lack of reliable generating, you know, lack of reliable generation capacity. But the root cause is that we just didn't keep things up to date for a very long time. We never, you know, nobody bothered to go update the, you know, nobody bothered to go update the, you know, the cold weather or the cold weather countermeasures, you know, on a lot of these like natural gas facilities all throughout Texas or through Michigan or, you know, wherever else, because, you know, they're up to code, and the people who did the calculations on, you know, on how likely some sort of, you know, major cold snap event was, you know, they you know, those calculations were considered to be relatively reliable. You know, and then Taleb's turkey gets its head cut off, and you know, we all see the whole situation for what it was the whole time, which was, you know, massive underinvestment in, you know, at every level of generation distribution and whatever else. And, you know, this is pervasive nationally. There were so many people who were picking on Texas. I think a lot of folks in California were sort of, you know, had a lot of schadenfreude there because everyone's giving them shit about, you know, about them not even having, like, the, you know, the power companies in California don't even have a full catalog of like where all their equipment is. Like, they literally don't know they don't have a map of where the power lines go. Which you would think in a state where, you know, where power lines routinely set, you know, routinely light, like massive, like 30,000 person town destroying fires, you'd think that would be a priority. But again, there's nothing requiring them to actually go do that. There's no enforcement mechanism, making sure that PG&E actually has a fucking catalog of where all of its wires are, and where all of its transformer boxes are. And, and instead, instead it's just some really bad conditions are allowed to persist. It seems to me to be just a pervasive cultural thing more than it is any single, this isn't the fault of like Jim Bob, the natural gas pipeline inspector, really. I mean, it kind of is, but not really. It's the fault of the group of administrators who haven't been practicing engineers in 30 years, who set all the rules, for this sort of stuff at the federal, state, local level. Right.
Yeah. I mean, my assumption, anytime something like that happens, right, like a large infrastructure failure, or like in my case, right, running a gym, sort of small, minor cascading problems typically occur, sort of like you were saying, both when there's an event that's, significantly outside of the sort of like expectation or what things are stress tested to. And then it's usually not one thing. It's like, it's a cascading series of failures, right? To use the gym as sort of a stupid example, it's like, okay, maybe we have a massive space problem, like utilization of space, when there's more people than normal. One person does one thing and goes somewhere weird, which causes someone somewhere else to go somewhere weird, which causes someone somewhere else to go somewhere weird. And it's like the sixth thing down the line where it's like there's more people than normal. A bunch of people made kind of bad decisions. Then all of a sudden something insane is happening. And it's not really anyone's fault. It's just like, this wasn't set up properly.
Right. Yeah. Like you get these failures that cascade into larger failures far quicker than people, or not people, far quicker than institutional decision making can respond to them. And I think that people need to really make peace with the fact that we're not going to have less of these as time goes on. Especially if we have a bunch of systems in place that we haven't changed in a really long time, or haven't even really critically assessed.
Yeah, well, and you mentioned like a cultural point. I mean, do you think that culture is enough to fix that? Is it just people being like, no, I refuse to allow you to let this be the standard. Like, this needs to be able to handle whatever, this many sigma outside of the expected, the expected load that this needs to bear, or whatever. Like what,
right?
Like what do you think is actually the way to change that?
I think it starts culturally. Like, there needs to be a big discussion with various different political and institutional stakeholders. I think it needs to be a frank discussion where a bunch of people say, we are going to exact severe consequences if this isn't, if this stuff isn't, if this stuff isn't solved. I would like to see, this is kind of silly, but, I would like to see more movies and TV shows where people make good, thoughtful decisions, and then that pays off. We shouldn't have one movie like The Martian every 10 years or Apollo 13 or what have you. So there's that cultural part of it, but I also think that it does come down to, people, like the actual working professionals in these, in a lot of these spaces. One of my favorite anecdotes just about the profession of engineering, which is a profession that many of us find ourselves in by accident nowadays, just as technical structured problem solving becomes more and more important, and as a wider and wider group of people do it for a living, is that there maybe aren't as many good parables for how to go about doing structured problem solving in a way that is ethical. And one of my favorites is one of my favorite parables of that type that some people might not know about is Isambard Brunel and the London sewers. Back when Isambard Brunel, who was sort of he was kind of like a Howard Hughes, Elon Musk type figure before there was aircraft or spacecraft, right? He mainly worked on locomotives and, the British railroad system, and then on steamships. He's famous for having pointed out to the naval architects of the Royal Navy Dockyard in Portsmouth that the surface area of a ship increases at the, as you make a ship larger, the surface area increases by the square, but the volume increases by a cube. Right. So, you can carry a lot more with a ship that isn't necessarily using, that much more, raw material to construct. But when he was designing the London sewer system, he got into this big fight with the municipal authorities over how large they were going to make all of these sewers. And Brunel went into meeting after meeting with these people in I believe it was the 1840s, and argued until his face was blue that this sort of stuff needed to happen. And they didn't, nobody was really having any of it. So he pulled out his trump card and he said he would quit. And at the time he was basically the only person capable of coordinating large underground construction projects of this type. He built the world's first subway tunnel with his father some years before. He went ahead and said, all right, yeah, well, if we don't make this many times what we need right now, we're going to regret it later, and I'm just not going to do the project. So they finally caved, and London still uses Brunel sewer system infrastructure all over the place. It's integrated with new tunnels that they've dug and other things along those lines. But, he was willing to go put, he was willing to go put his job on the line over issues like this. And I think that more people in technical professions need to go find their spines, quite frankly, and enforce some of this stuff, because if we don't do it, no one will. That might sound a little bit harsh to a lot of people who have been putting in a lot of work to keep the infrastructure running, but it's not wrong.
Yeah, so it's more dependent on the people who have the technical knowledge to understand what the trade-offs are between whatever, trying to cut costs right now versus being unprepared for a future event or not robust enough to potentially handle something that's outside of the norm by a certain amount.
Right.
And it requires people to be willing to say, listen, I'm going to actually refuse to do this unless we make this the right way.
Yeah. And to do so on ethical grounds, I might add. Most of the time people are sort of trained to object to stuff on commercial grounds. So they'll go and say this might not be able to serve the amount of customers we have down the line. This might not be a great idea. But when you start to look at things like, base level computing infrastructure, base level communications infrastructure, the electrical grid, water, sewage, yada, 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 you start to see situations where it actually would be helpful for somebody to actually pull the moral card and say, this sort of thing ought not be permitted. And, it's our responsibility to fight like hell internally to make sure that it isn't permitted in the future. And that's how you avoid little girls freezing to death in Dallas, Texas, right? Like that, that's how you avoid, that's how you avoid, unpatched security vulnerabilities in the federal Department of or in the Federal General Services Administration database, which the some foreign state actor stole several years ago. That sort of stuff is important, and certain things shouldn't necessarily be made, or certain decisions shouldn't necessarily be made with cost benefit trade-offs, being prioritized over every other decision-making factor. You know what I mean? Or with cost benefit trade-offs, they're scoped to like a very, that are optimized around like local conditions as opposed to like the long term.
Like a simple expected value calculation on something like that is not necessarily going to give you the right answer when you consider that it's part of a complex system that, could have runaway effects if things are not handled correctly.
Exactly. And like, I don't want to rag on Econ 101 because Econ 101 is a bunch of, really useful like the really useful baseline heuristics for looking at human behavior. But like, you can't use Econ 101 models when you're plugging data into them that will that maybe isn't necessarily reliable, like historic stream gauge data for flooding, that is, as you said, it's a dynamic system. It's changing, right? Floods are getting worse. We have 100-year floods every 5 years now, in some places. And yet people don't really do that much to update the calculations behind it, and certainly not the infrastructure,
So you started to mention some data infrastructure kinds of concepts, and I know you have a background in that stuff, and at least from a user of the World Wide Web and computers, it seems that we've done a better job of making those kinds of infrastructure decisions with like technical projects in the computer science database internet realm, right? That like certainly there's outages, things go down, but it actually seems to work shockingly well. Is that just because it's easier to do with like bits and bytes, and you can fix mistakes without having to rip down like an electrical grid and rebuild it? Like what's your take on that?
I don't know. The facile sort of libertarian take is just, it's more advanced because we weren't regulated, right? Which isn't entirely, that's not true at all. There was a lot of regulation around, around telco in particular. Telco is, a quasi-nationalized industry in a lot of ways. I think that might be better because it's military adjacent. The communication systems that put it this way, the United States military uses TCP/IP, right, for basically everything. And if you use TCP/IP for basically it, for your drones and your, a bunch of other systems that need to talk, it's worth making sure that that's robust. And, a lot of countries are actually still quite good at making sure that their military technology is robust. There's some extent to which communication systems are weapon systems, and, we put a lot of work into them. That is an argument I've heard before. I think it's partially true. I think you're probably right that there's a lot of, you just don't have a whole lot of, like, there just isn't nearly as much risk involved with the failures of these sorts of systems because people don't tend to see them, right? Like, if your bank goes and deletes a bunch of your data, right? As long as they still have your final ledger number, they can just say like, oh no, well, where'd all your account records go? Archived, that sort of stuff. And that crap happens all the time.
Where's my MySpace friends list, Tom?
Yeah. Where is my MySpace friends? That's a really good question. So there's that. I think there's the issue of but so when you have that relatively low level of risk, you tend to develop a culture that is a lot more experimental, right? And I think that having that experimental culture is actually where most of the rapid advancements and the now just sort of magic stuff that the telecommunications and computing infrastructure can do came from. Like people actually had the room to experiment, and that hasn't been true in civil engineering since the Eisenhower era, and hasn't been true in aerospace, less certain space systems, since at least the 70s. Hasn't been true in a lot of areas since the 70s. So, I think that a lot of that just does come back to cultural assumptions around risk. There's this whole cottage industry of financiers, formerly out west and now spread all over, who got acculturated to that, who were open to throwing the comparatively small amounts of money, but still, not nothing at solving various different novel and interesting problems. And yeah, a lot of good has come from that. A lot of the systems that, that have been built as a result of that have had positive effects elsewhere. And yeah, I think it's not that technical infrastructure or that digital technical infrastructure is better because it's lower risk. It's because in a lot of cases it's not. Like we could have a cyber attack that could bring down the grid tomorrow, right? But rather because the risks are not considered to be an impediment to developing past them. Does that make sense?
Yeah. Well, yeah, I mean, to use sort of like a superficial analogy, right? I mean, anyone who is learning to code probably learns some basic form of version control at some point, right? So
you'd be surprised, but
yeah. Well, yeah, sure. As a hack job coder myself, I will admit that my habits are poor. But right, I mean, for listeners who maybe don't have a background in this stuff, right? You can set it up so that as you make changes, you can sort of save your project at each stage where you're like, okay, I added this feature, I fixed this bug, and then you try to run your thing and it breaks everything and you're like, uh-oh, and then you just revert it to the previous version that worked, right? So there's a safety net with a lot of software development to taking that risk, right? You can break everything and then just be like, oops, and revert it, and to use a more whatever culturally salient example, Facebook's early slogan of move fast and break things, which I think has been, used culturally to their chagrin as well.
I think they're now move slow and don't get called in front of a congressional committee.
Yeah, totally. Yeah. We had to switch a few words there.
A little bit of a priority shift. Yeah. Sheryl Sandberg era is.
But to your point, right? I mean, the point of that slogan was like, hey, yeah, you can ship a new version of the app right now and see if people like it. And oops, like it broke everything and a bunch of people can't log in or whatever. It's fine. Just revert it to the previous version that worked. We at least ran an experiment and we found out, right? And there's obviously potential downsides to that when you deploy a massive social network to the entire world and maybe don't properly consider the downsides of connecting everyone. But from a pure, like, let's make infrastructure and code that works, it seems to be a much better way. So is there a way with more physical infrastructure to recreate that idea of just like having version control, enabling people to experiment and find new solutions to problems?
Yeah. I mean, the example that we have that we don't actually utilize is the Idaho test site for nuclear reactors, right? So we developed a couple generations past, and they term it very specifically in the nuclear industry, but for the layperson, like, you can think of this as many new generations of reactor. And they prototyped a bunch of this stuff out on the Idaho test site, far in the middle of nowhere, where, you can put a big nuclear reactor that might blow up and not too many people would be injured by it. And yet we don't use that sort of stuff, right? So I think one way that we could, that we could get to iterative development of physical infrastructure is to literally just fund it, which is not something that we do all that often. People may recall the running infrastructure week joke about the Trump administration. It's something that we've talked about for a long time, but that we never do, no matter how many, big bridges in Minneapolis collapse or levees fail or whatever else. Actually, we have put in some work on the levee thing. That's been a little bit better, at least in the lower Mississippi. But
yeah, anyway. Levees are a shining paragon of infrastructural improvement.
No, the Army Corps just doesn't need to ask permission in most cases.
Oh,
you know what I mean? The Army Corps can show up and for whatever reason, that sort of water management, they often have. Extra jurisdictional powers over, or they're working with like some sort of extra jurisdictional entity to do a bunch of water infrastructure management. The Tennessee Valley Authority is a great example of this, and all the huge hydroelectric dams they run. But yeah, they after Katrina happened, there were a lot of places where levees got fixed up, but there are a lot of places where that hasn't happened, or where even more consequential structures like full-size dams haven't been built out to specifications that they ought to. And it's since everybody can like see what happens when a levee breaks or a dam fails, everybody can, we have this like deep ancestral memory of how bad flooding is. People usually are willing to say like, okay, all right, this is a problem that the layperson can grok very clearly, like, big wall of water coming towards my house, not good, right? So it's something that we can marshal resources around.
As discussed previously, there's like a flood-sized shape in our brains too. That's like, we don't want that.
I like that arachnophobia thing, but I mean, yeah, like if you're from Western European or Western European culture or Southeast Asian culture or wide range of other places, not only have you had for centuries, really for all of human history, this like idea of, rating flood risk, right? But you've had some of the first like modern governmental institutions in the world, put together to go manage those problems. China developed some of the world's earliest and most complex bureaucracies on the basis of water management. Same thing with Egypt. This is thousands of years ago, right? So, we've got a lot of reps in on the whole water management thing, and that I think makes us slightly better on that than other problems. And again, it's a visible thing. It's not a coal power plant slowly changing the bark of all of your willow trees black, over the course of like 20 years, and it's a big, sudden, bad thing. We can get pretty good at dealing with big, sudden, bad, predictable failures, right? But the complex emergent stuff requires a completely new attitude around risk, I think.
Yeah, and so you said just the idea of like, hey, literally just fund it. Like, what do you mean by that? Do you mean that the government should be funding companies to try to attack these problems? That there's obvious examples of some success with that with some environmental projects, right? I mean, Tesla being a current thing in the news with that.
Yeah,
right?
Yeah. I mean, the feds successfully memed both solar panels and windmills and wind farms into existence, with lots of subsidies. So, it's possible to go do this stuff. We just, we don't necessarily target it very well. We would be better off, and I'm going to get yelled at for saying this, but we would have been better off if every single one of those dollars dropped into renewables had just gone into nuclear, in my opinion. We would be in a position where we have reactors that can, for example, slot right into the thermal generation infrastructure that we've built for coal plants. This is something that they're working on in Britain and Canada that we have no ability to work on here because the Nuclear Regulatory Commission has just not only have they decided to like prohibit commercial development on it, they're just not funding the academic research sufficiently, at the level of the Department of Energy or at the level of universities.
So this is maybe a good example to dig into, since I think you're pretty knowledgeable about this, and I'm not, right? I mean, I have vague ideas about nuclear, but not anything that's particularly well informed, right? So, I mean, my sort of layperson outsider understanding is that nuclear is effective if it is up and running, and that it's extremely expensive to get there, and that due to the cost,
yes,
that we have essentially not funded it, and also some of the political cost, because it sort of like we said before, it is a type of thing that people are prone to getting upset about, where it's like, okay, this is politically expensive, this is financially expensive, it's not worth it. So if you were the head of the money bureau, and it was like, all right, Matt, like, fund this infrastructure project, figure it out, what should be done?
With nuclear specifically?
Yeah, totally. Right. I mean,
abolish the NRC, adopt British regulation wholesale, and then throw 1% of GDP at it.
So you think if there's just like enough thrown at it that the cost hurdles are overcome?
I mean, you need to get the NRC out of the way.
Tell us more about the NRC.
Yeah, so the Nuclear Regulatory Commission was one of these great sort of mid-century regulatory institutions that's just designed to stop anything from happening, and they've done so quite successfully. They regulate on the basis of a lot of very arcane and not particularly scientific so instead of assessing risk like the Brits do, so the Brits and the Canadians assess risk on the basis of like scientific first principles and a case-by-case review, right? American nuclear regulatory frameworks and I might be wrong about this, but I think the Japanese as well, because they're one of the other large nuclear producers. Hitachi makes lots of makes reactors. Though the regulations in the U.S. and in countries that have copied U.S. regulation are just based in instead of like a first principles assessment, like they qualify components of the reactor basically. That's a gross oversimplification of this, but that's of what they do. But it's basically what they end up doing in effect. And part of the reason for this is that our entire nuclear reactor fleet is with a few research reactors here and there as exceptions are just light water reactors. And the reason for this is that. There are, is because those were useful on submarines and on aircraft carriers, right? So Hyman Rickover, Nuclear Navy, that whole thing. Go read the Wikipedia article. That's any of the listeners who aren't unfamiliar with that. It's a fascinating story. But as a result of that sort of development, the NRC basically started to look like an F-35 style acquisition program more than a thoughtful regulator. And the consequence of this is that we haven't built a new reactor in the United States in quite some time, and we're probably not going to until we, legislatively remove the NRC from the position that it's in. So yeah, I would get rid of the NRC entirely. I think most Americans would be perfectly fine with like a bunch of physicists just sitting down and doing some risk math, just assessing things, from first principles rather than assessing things on the basis of, dumb acquisitions rubrics. And then I'd just throw a bunch of money at it. And I think that combination of things would lead us to what we've known as the solution since the 60s, which is low site cost modular nuclear reactors that you can fit on the back of a semi-truck. And if you can build your reactor and fuel it off site and just drive it to some standardized plant that could be wherever, and then just plop it in a tank of water and let it run for 5-10 years until you have to refuel the thing. That is a model for nuclear that is going to outcompete. That's a model for electricity generation that is going to outcompete everything, and it's not even going to be close in terms of cost. The whole, there were all these, back during the Atoms for Peace era, back in the 50s, there was all this propaganda about energy eventually becoming, at least at the consumer level, not at the industrial level, but at least at the household consumer level, energy becoming too cheap to meter. And between rooftop solar panels and the deployment of modular nuclear, small nuclear reactors that we know work because small nuclear reactors of various advanced types have been deployed on ships, and have been developed extensively by other countries. As soon as we deploy that sort of thing, we actually will be able to deliver within probably a decade or two on too cheap to meter electricity. And if you're kind of if you're someone who's willing to entertain sci-fi fantasies of what the world might look like, you see this, you can see this pretty clearly as that's step zero for genuine no bullshit post scarcity, because energy's an input to everything.
Yeah, it's an input to Bitcoin. So just use the modular nuclear reactors to.
Okay, so a few caveats here. And I'm going to get myself in trouble again from a completely different angle. That would most likely not be the best use of yeah, spinning a bunch of GPUs all day, probably not going to be the best use of reactors. But I would say that you can power a lot of other processes with just electricity. You can do a lot of things. You can do a lot of heavy industry stuff with just electricity, and what we would be looking at in addition to the post scarcity stuff is the eventual just economic eclipse of large scale petrochemical combustion as a way of making watts, and that for whatever purpose, for whatever industrial purpose, whether it's grid related or not, and that is a goal that we ought to shoot for, not just because not just because of the health implications of coal plants or the global warming implications of carbon and methane releases, but just because it's, frankly, in my opinion, more aesthetically pleasing and elegant to use the nice little pellet of uranium to uranium or eventually thorium or whatever fuel stock you're using to power our daily lives. I think that it's just it's a slam dunk. I don't know. And this is kind of turning into me doing my rant on reactors.
Dude, that's what I wanted. That's
well, I wish more people would listen to this down in DC. This is one of those programs where the ossified Rooseveltian institutions that can't seem to manage anything could actually just roll in, pick up where they left off in the 50s, and make a serious win for the human race. And they just don't.
Well, so let me ask you this, and you're using the UK as a model for something that works better, right? That they don't have a sort of cover your ass, whatever case law focused bureaucracy, and they potentially have more folks trying to think about these problems. Are they making progress based upon that, or are they stuck too?
They don't have the money.
Got it.
I mean, they are making progress, but the amount of capital that the British government can aggregate to throw behind something like that is a tiny fraction of the amount of capital that the U.S. government can aggregate. I mean, for context, Britain is very near to not having an army anymore. That's not the only thing they're not funding. Britain is in the position of essentially outsourcing its security to the United States, and in exchange they just run spy agencies.
Yeah,
you know what I mean. GCHQ is probably better than the NSA in a lot of respects. So the Brits have made similar bad decisions. Their regulatory framework is just a lot less bad. So in places that in places that model their regulation on British regulation, you just see a bit more research and a bit more, and a bit more serious work. I think that there's there's a version of this pitch too that's kind of chest beatingly American and sort of NATO nationalist a little bit that I hope will scare people in DC out of their complacency with this stuff, and that's that the Russians and the Chinese are sprinting ahead on small modular nuclear reactors, and there's a version of the future where Anglo-American control of the world's energy supply disappears over the course of 5 years because the Russians and the Chinese are just shipping out modular fueled reactors to people. all across the world for very cheap. And that is not a world that anybody wants to live in. We will eventually get to the point where we finally like just make peace with the physics and nuclearize the whole grid, and do that across the world. But it's going to matter quite a lot who does that. And I think that should be, more liberal, freedom oriented Western states, and not kleptocratic oligarchies.
Totally. Well, yeah,
to the extent that we aren't a kleptocratic oligarchy in our own special way. That's a whole nother podcast episode.
on a relative scale, there's relative degrees of kleptocracy.
Right, exactly. We're just
differing oligarchies.
The American or the Brit is just a tax is a tax cow, milked by the state, but at least the American or the Brit or the Aussie isn't a almost literal serf, like is the case in a lot of in a lot of the Russian economy or I wouldn't use serfdom to characterize how the economy of the People's Republic of China works, but it's certainly not the level of citizenship that we expect elsewhere.
Yeah, there's some sort of with great GDP comes great responsibility aspect of it as well.
Yes, absolutely. Absolutely. Like, if we're going to have these huge monstrous institutions, we had better do something good with them. You know what I mean? The Royal Navy did a lot of bad shit, right? Like, they were the Vikings of the 19th century. But they also got rid of the international slave trade, and I figured, if we're going to have these big, unwieldy, monstrous institutions, let's at least take advantage of the economies of scale that they provide, and make electricity free.
So let's talk fabrication too, right? We're talking big, large scale infrastructure, intractable global problems. But what about people who want to build small stuff?
Thank you so much for teeing up that lovely softball. I will wait until the end to shamelessly pitch. But we're seeing there's going to be a lot of stuff that happens over the next 5 or 10 years that sort of applies the same logic to various components of physical infrastructure. Basically, we're going to see the big iron. If anyone is familiar with this, basically during the like 60s, 70s, 80s, most computing was done on what we in the business would call big iron. So big iron is like those very aesthetic looking, like lounge chair cum supercomputer machines that Cray would build, or it's like a 6-ton IBM behemoth, right? With 800 whole megabytes of memory. And we were in this model for a very long time. And, this was the period where everybody was saying like, oh, well, I have a computer, and, the response would probably be like, in your warehouse. If that makes sense. And then all of a sudden, and kind of out of nowhere, as far as the legacy players are concerned, personal computing popped up. And one moment personal computers weren't useful, and then another moment they were enabling business models, that couldn't exist before. And, they drove last mile network infrastructure build out, and they did all of this other stuff. And, and everybody's very familiar with how beneficial it was for us to walk down that S curve in computer costs. And now we're kind of at the, in some respects, like Moore's law is over. We're at the bottom of, the, of that big cost sigmoid for computers. And I think everybody understands how great that was for humanity that we went and did this. Cause like, unless you are a Luddite shut-in, this probably is, this computer revolution has probably delivered a lot of good things for you. A similar big iron to commodity, to small commodity, small scale commodity, small scale at the unit level. I probably need to figure out a better way of saying that because this is part of it. But that same sort of big iron to commodity server or desktop machine or phone transition is happening in a ton of other places. The area that I'm most interested in is robotics and machine tools, but that is not the only spot that's happening in. It's happening with somewhat scarily with weapon systems. Drones. Drones now commercial quadcopter drones mean that non-state actors get to have an air force now. That is totally changing the way conflict, like armed conflict, happens. So we're currently walking that cost curve right now. The cost curve for sorry, I should say the cost sigmoid, not the cost curve, because that means something specific in econ and
yes, a reserved term. Yeah,
exactly. Excuse me. I need to not remap that to something that Colin would yell at me about. So we're seeing that with drones. We're seeing that with certain things in biotech. We're seeing, certainly like, genetic engineering. That wasn't really a sigmoid. It was a step change. It was like there was the world before CRISPR, and then there was the world after CRISPR, and it's night and day there. So there are sharper transitions in different in various different fields, but as a general rule, complicated stuff that used to require really high capital density to buy the equipment to do, now requires significantly less capital and oftentimes significantly less physical space. And oftentimes it's also networked. In fact, almost all the time it's now networked and manageable from a distance. You can put a computer in it, and that computer can make not necessarily better decisions than humans can, but it can definitely make faster decisions. And all of that comes together in any given field, whether it's drones or machine tools or what have you. And it creates new markets, it creates new business models, and it creates, over time, if deployed correctly and if unencumbered by state interference or big corporate interference or big corporate and state interference or, all these other things, it tends to generate a lot of prosperity. So yeah, I think that, like, what we've been talking about is kind of, thus far has been what the kids would call black pill, right? Just intensely discouraging, an intensely discouraging assessment of how shitty things have gotten, with large scale infrastructure.
I'd argue slightly, because I think black pill is like a very sort of nihilistic, assume everything is caused by weird bad intentions and like malicious actors. And I certainly think that that's part of what we talked about. But I think a lot of it is just like, oh, this is an inevitable consequence of certain types of institutional rot, and it's a really hard problem to solve. Which is, I don't know what color pill that is, but that's the pill I took. Personally.
Yeah, I mean, we need to start inventing various different types of pills. In fact, I would like to move out of just like the color spectrum of pills, and I think we need to go into like maybe shapes or higher dimensional shapes of pills and other things. I'm fucking around, but anyway. Totally. But yeah, I mean, whether it's just like a, whether you look at this hairy problem and say we're all screwed, or whether you look at this hairy problem and say it's a hairy problem, we're just going to eat it one bite at a time. Things are not great when it comes to like infrastructure that works at the large scale. But if you look at the small scale, things are getting really good, really, really fast. Rooftop solar and eventually batteries in the house are going to, like, the combination of those two things is going to make for a much more robust electrical grid, regardless of what our baseload generation capacity is, right? Like, is made out of. We have room for improvement there that doesn't rely on big collective action problems being solved. There's another, there are a number of other areas that are getting better quickly. The ability to dispatch, drones for security purposes, the ability to, to use them to get to places where people can't. All of the various different, like, really dirty, really unsafe jobs that people, that people often like didn't want to do, and that had, very few takers as a consequence. A lot of those are getting safer as a consequence of, mobile and rapidly advancing robotics. I think people tend to underrate small scale stuff like this. Yeah, I mean, do you want me to get into the machine tools thing a little more deeply?
I want to know about it.
Okay, so basically, we're sitting on top of an enormous S-curve, in machine tool cost. And this started sort of with 3D printers. A lot of people.
Can you just define machine tool quickly?
That's a really tough.
Sure. Well, yeah, but just like the class, like what are some examples of the class machine tools?
Lathes.
Right.
Lathes. Various different forms of mill, various different forms of mold. All just machines you use to make stuff, right? Like the things that. The things that are like 1 or 2 steps or 3 steps or 5 steps up from consumer products in the production chain, right? Those are collapsing, like, in cost and in complexity and in weight, very quickly. So, 3D printers went from relatively low quality machines that you could buy for like $50,000 or more. That was like the starter price. Back in the 90s and aughts, to a machine that can do comparable things in the right conditions for like $1,000. Whenever something like that happens, it has enormous knock-on effects. So all of those robotics, collapsed in cost, and, people are probably at this point asking, like, okay, well, what does this have to do with lathes? Well, you can't have a traditional like machining process ride on chintzy like 15 pound or 50 pound robotics, because it's just going to tear everything apart. The forces are too great, right? But you can definitely do electrochemical machining on that sort of set of robotics. Problem is, though, that like this like electrochemical machining work has been sort of the province of like very esoteric aerospace applications, right? And all of those machines cost, much like the FDM 3D printers, 10, 15 years ago, they cost like 50, 100 grand, just at the entry level. There's all sorts of goofy considerations with setup. Not many people have experience designing for that sort of process, and so on and so forth, right? But it's capable in its present form of doing most of the things that traditional subtractive machining with metal on metal can do. And since it can ride on extremely cheap robotics, we're not very far off. Probably, I would say like 18 months until the open source community has like a good grasp on how to do this before we have ECM working at pretty high levels of precision on commodity robotics. So that in practical terms, that means that a Haas single axis mill, which costs minimum like 50 grand, is going to have to compete then with a probably $2,000 to $3,000 or maybe less dollar machine that does ECM. And that will probably emerge in like the next 18 months. That might be a little optimistic, but that's roughly what I expect. And you start to go through the set of industrial processes that we have access to, welding, sintering, doing all this other stuff, right? And if you just pick the ones that don't involve serious forces, you can probably make them run on cheap commodity robotics. So I don't know what like the fine grain picture of a like post machine tool commodification world. Like I don't know. I don't have a fine grain picture of what that world looks like. But I know that it is going to be radically different from what we have right now, because it's going to reconfigure lots and lots and lots of economic structures. And I think it'll do so very quickly, because if you lower the capital costs of getting into manufacturing, the chances of you bootstrapping from some camera accessory to bootstrapping from some cheap plastic camera accessory that would normally require injection molding and design for manufacturing processes that take months and all this other stuff. If you can go from that then to slightly more complicated components and buy a few more printers, and then slightly more complicated components and buy some ECM rigs, and then slightly more complicated components and buy some other stuff, pretty soon you're looking at mom and pop sophisticated electronics shops. And the only equivalent in history that I can really think of here is like watchmaking and precision instruments proliferating through Germany and Switzerland back, way back in the day. That might be a model to look for. But this is going to happen a lot faster, and it's going to happen a lot more broadly. And I think it's going to completely change the global economy. So I call the stuff in this sort of realm of low cost, high productivity manufacturing equipment. I call that like fab tech. That's sort of the buzzwordy kind of thing that that we've been mapping this whole like set of concepts and emergent technologies too. But I don't know what it looks like on the other end of this, but it's going to be really cool.
Well, to your point, it's difficult to say, oh yeah, we're going to try to make these computers talk to each other. And, people probably have an idea of some of the things that people might want to do with that. But I don't think anyone was like, okay, yeah, that will definitely result in Wikipedia.
Right. Exactly. There's no way to predict the emergence of like a anarchic global commons of information or of encyclopedic information. You know what I mean? I don't think that was in anybody's cards. You know, William Gibson in Neuromancer, which is this great cyberpunk book. He has this trope where it's, in Neuromancer is, in terms of the megacorps and the ubiquitous air travel and the beginnings of easy access to space and all this other stuff. It's very descriptive of, where we are today, but something that he didn't predict were, low level, like he had this very high resolution picture of the future in the 1980s, and most of it has come true. But he also predicted that, no one would have guns. And it turns out he was very, very, very categorically wrong about that, because it turns out you can 3D print most of a gun and you can ECM the rest with jigs that you 3D print. And there's going to be unexpected stuff like that popping up all over the place. Some of it'll be scary. Some of it'll be, unexpectedly great. But, I think a lot of people should probably start thinking now about what they could do with significantly cheaper machine tools, about what they could do with significantly cheaper drones, about what they could do with significantly cheaper just robotics generally. So yeah, I mean, that's an area where I'm, having seen this whole thing break out in a really big way in the last 18 months or so. I'm very excited about, the potential for that to deliver a lot of, opportunities for enhanced human flourishing.
Well, Matt, what are you going to do about fab tech?
Softball pitch number 2. My good friend Nick Armstrong and I have just incorporated a company. We're calling it General Fabrication. We are basically setting ourselves up to eat upstream complexity for operators of fabrication facilities, for fab operators. That's going to initially look like 3D printing farms. And we think we can enable people and like guide them through, sort of accessing these novel business models. We think that, that's what the first stage looks like. It's high value, low widget count, plastic parts that you can sell via direct to consumer routes. We think that since the direct to consumer revolution has happened, it makes sense to now make that for us to now have the direct from producer revolution and not indirectly via 5 shipping containers from Vietnam, like that, so that's a business model that we intend to enable. And then we just plan on facilitating more and more sophistication, for these, for small and then hopefully eventually medium size and then hopefully eventually large, fabrication, operations. We're going to be supporting a line of free open source hardware, for this sort of thing. It's of our view, we are of the view that, that it really does make sense for a lot of this stuff to be standardized, standardized and fully open source. We intend to make money on, by not just like developing and selling open source machinery, because once you've open sourced it, other people can copy you. And we intend to be better than a lot of those competitors in tangible ways on the manufacturing side, or on our own manufacturing side. But we also intend to do a lot of things that don't directly relate to 3D, running a bunch of 3D printers and eventually a bunch of VCM rigs and eventually a bunch of pick and place machines. We want to eat upstream complexity for people who are starting new businesses in this area. So please reach out to me, Matt at genfab, genfab.co, genfab.co, Matt at genfab.co. Send me an email there or hit me on Twitter if you are interested in working on this, because we're going to be hiring a bunch of people. If you are interested in screwing around with the 3D printer to figure out how you could potentially build a business around some of this stuff, because we can probably help you with the initial stages there, and we would very much like to know what your concerns are so that we can shape our products better. We are also raising a pre-seed round right now. Thankfully, we can sell things on enough of a margin that the future looks pretty good for the firm, even in the event of us of us being maybe a little slow on the fundraising. But yeah, we're hoping to close that gap relatively soon. And we want to we want to do our tiny little part in in helping enable a concrete vision of a post-scarcity future. We want to make we want to put in a lot of work to increase the material abundance that people have access to, and we think that's a really worthwhile problem to go spend our time on. And frankly, I think we could not have picked a better time to jump in on this stuff, because this is a market that, with or without us, is going to just explode massively. I really do think that in 5 or 10 years, we're going to see a complete reconfiguration of manufacturing to a level that is more economically consequential than the reconfiguration of retail around outfits like Amazon. And I'm not saying that we're going to see an Amazon type firm emerge. There may be some terrible regulation that causes industrial concentration on this. That's always a possibility. But absent very problematic state intervention, we think that there's a lot of inevitabilities baked into some of the economics here, and baked into the technological components that we have. So
yeah, well, there's a big difference too between a behemoth like Amazon or any other type of e-commerce situation, or something like Netflix or whatever, taking advantage of the economies of scale provided by the internet, versus something like, let's say, Shopify or Stripe or whatever,
right,
that facilitates a bunch of people coming online,
yes,
and taking advantage of infrastructure that was previously inaccessible and required all kinds of headaches and technical capacity in a multitude of different fields to even be like, yeah, I'm going to put my product online, right? And you're attempting to provide that infrastructure on a physical basis rather than on a digital basis.
Yes. Yeah. So basically, a user story that we imagine being able to provide within 6 months or so is in a couple select cities to be announced. We're going to have service centers. Those service centers will essentially enable us to send a van with a replacement machine that we can just plug into a rack on your wall as soon as you have a fault with one of the machines that we support.
There's the Red Hat parallel.
Yeah. Yes, exactly. I mean, there's Red Hat parallels, it's in physical space, and 3D printers aren't the kernel. ECM rigs aren't the kernel, but a lot of the stuff is very similar. And one thing that Red Hat does is it eats upstream complexity for businesses. Businesses are not going to want to, like, modern Linux based software development would be a lot harder if we didn't have systemd. And the folks at Red Hat help provide that sort of thing. And that kind of stuff is that kind of stuff is relatively valuable to to their customers, and we think we can do a similar thing for folks. We want to enable as many people as possible to start new manufacturing firms, because there are the net benefit of democratizing industrial revolutions is significant, right? And we think that we think we can create a lot of prosperity and spread it really widely with this set of technologies. Because, man, I mean, imagine like what some like benighted, like economically left behind, a population center could do with the ability to spin up factories for, a tenth or a hundredth of the cost that was previously, that was previously implicit in that sort of thing. I think that has a lot of really positive economic implications.
Yeah, that's
just one version of it.
That's exciting, man. I'm really excited about this.
Yeah. Well, dude, we need to put a printer in your gym.
All right.
we need to.
Dude, we break our stupid plastic plates all the time, man.
Yeah. Yeah. Well, I mean, it's one of these things where it's like, it's. And it's not even like right there. It took you approximately 0 seconds to think of somehow, some way that this sort of thing would be useful, right? Like, and there's that's been one of the most rewarding parts of this, right? Has been sitting down in a room with somebody, or on a call with somebody, and like walking them through like, what all this looks like. And then you see the eyes light up and they're like, oh, interesting. This could be fun. This could be neat. There's a lot of opportunity to go do stuff. And we're not we're not just competing with with injection molding when we roll out product suite like we're rolling out. We're competing with the entire like finicky design for manufacturing process that you have to go through, so if there's something you think you could sell, if there's like a plastic part that you think you could sell for like $50 to $70 or even like 20 or 30, and it's not particularly large, like maybe a few of them can fit on a build plate that's like 200 centimeters by 200 centimeters, or sorry, 200 millimeters by 200 millimeters. Like, seriously, get in touch with me, because like I really genuinely think that you could set up the sales channel quickly. You could set up the nuts and bolts of the like the business and distribution pipeline very quickly, and we can bring the manufacturing the manufacturing components, so that you don't have to go to Shenzhen and subject yourself to their new and interesting COVID test procedure. So, and I'll let everybody go look that one up, because I don't want to get into that one. But
I'll have to Google it right after this. We'll see.
It's gross.
Dude.
Involves fecal matter sampling. Anyway.
Oh God. Uh-oh.
I don't mean to throw I don't know. I shouldn't do that to your audience. I apologize.
It's okay. They can take it. Well, yeah, Matt, you mentioned the website, your email, Twitter. Is there anything else you want people to do if they enjoyed this conversation and want to learn more?
Seriously, reach out. Nick Armstrong, my co-founder, and I are both very, very accessible people. You know, DMs are open on Twitter. I'm at Matt, M-A-T-T, Parlmer, P-A-R-L-M-E-R. There's an extra R in there. French Canadians, you know, obnoxious, but it is what it is. Yeah, ping me. Like I'm really, really interested to hear zany ideas around some of this stuff, because I think there are a lot of like multi-million, billion-dollar zany ideas that are, you know, that could be enabled by you know, 100-fold decrease in machine tool costs. And
yeah, they're about to come online.
Yeah, like I you know, it is I think it would be, you know, like if you have you know, people, like right now, we think over the next 6 to 9 months, our best customers are likely to be people who are really like deep in some hobby or in some sort of like niche, you know, like in some sort of profession that requires like really niche tools, like, you know, jigs or you know, other like weird alignment components and stuff like that. And we think, you know, there are a ton of businesses that don't exist yet that could exist and could, you know, potentially be extremely lucrative for whoever starts them. And if people are starting novel manufacturing businesses and buying our products and letting us handle quality control upstream of them, that's good for everybody. So drop me a line.
Hit me up.
Hit me up. I want to put a printer in your garage.
Thanks for listening. If you like the show, the best thing to do would be to send it to one of your friends who also likes podcasts. If you want more, I have an email list where I send out a weekly update with all of the podcasts I've recorded and articles that I've written. I also include my favorite things that I've been reading or listening to as well. You can sign up for that at www.toddneve.com. That's I before E, or you can open up the show notes in your podcast player and click the link in there.